In part 2 of our review of exponential relations, we're going to focus on word problems. In our first one, we have the population of orangutans that is decreasing at a rate of 13% per year. If Indonesia has 112,000 orangutans in 2015, how many are there after 5 years? So we're going to be working with our basic exponential relations equation, which is y is equal to a times b to the power of x. So we need to identify what information we are given and what information we are looking for. So our a value, this is our starting number or initial number. This is the number of orangutans. So 112,000 orangutans. Now, we are told that the population is decreasing at a rate of 13% per year. So this is going to help us to calculate b, because b is our decay factor, and it takes into account the decay rate. So when something is decreasing or decaying, we use b is equal to 1 minus r. So r is going to be this rate of 13%, but written as a decimal. So if we divide by 100, we get 0.13. So we're going to be using that. So b is equal to 1 minus 0.13, and this gives us a value of b being equal to 0.87. So we have a, we have b, and we are told that that this 13% is per year. So then we are asked, how many orangutans will there be after 5 years? So this is our x value. X is equal to 5. So we have a, we have b, we have x, and we're looking for y. Y is going to be our new population after 5 years. So we're just going to take all of the information we are given and we are going to put it into our equation. Now, when we are doing this calculation in our calculator, all calculators are different. Some of you will be able to punch this whole line in your calculator, and it will do BEDMAS for you, right? It'll do the proper order of operations. Not everyone can do that. If your calculator does not do the order of operations for you or BEDMAS for you, you need to calculate 0.87 to the power of 5 first, okay? That needs to be done first. So I'm going to do it in 2 steps, whereas some of you may do it in just one on your calculator. So 0.87 to the power of 5, this gives us 0.49842 and so on. So we don't want to round our numbers yet. You should be able to just keep that number in your calculator and then multiply it by 112,000. This is going to give you, this is going to give you 55,823, and then it's like 0.14 and so on. Well, we can't have part of an orangutan, so we need to round to a whole number. So you get 55,823. Now, because it's a word problem, we should write a summary sentence or a paraphrase. So therefore, there are 55,823 orangutans in Indonesia after 5 years. Okay, so that was our question that dealt with decay. So now we're going to look at a question that deals with growth. The population of Tiny Town is 345. A new company sets up in town and the population starts increasing at 21% per year. How many people are there after 7 years? So we're going to do the same thing we did before. We're going to be working with our basic equation, y is equal to a times b to the power of x, and we're going to identify the information we're given and the information we need to find. So we are told that the population of Tiny Town is 345. So a is equal to 345. We are also told that the population starts increasing at 21% per year. This means that we're looking at growth. So b is equal to 1 plus r. Now remember, r is going to be our percent, So here we have our 21% written as a decimal. And to do that, we are going to just divide by 100, which gives 0.21. So b is equal to 1 plus 0.21, which is 1.21. So we have A, we have B, and we are asked to find how many people there are after 7 years. So x is equal to 7. And y is what we're looking for. That is going to give us our new population. So let us put in all of the information we have. And just like the previous example, if your calculator doesn't do BEDMAS for you, please make sure that you do the exponent first before you do any multiplication, because that exponent of 7 is only on the 1.21. And if we do that calculation, it gives us about 3.797 and so on. Again, don't round until the end. Then we multiply that by 345 and we get 1,310.13 and so on. But again, we cannot have part of a person, so we need to round this to 1,310. And now let's write a summary sentence. Therefore, there are 1,310 people after 7 years. Okay, 2 problems down and 2 left to go. Next one. A population of ants starts with 50 and grows at a rate of 3.7% per week. What is the doubling time? So here we are introducing some new terminology. Again, if you're not 100% sure about doubling time, go back and look at the notes for the unit that are on the Google Classroom. They were actually with the previous lesson. They were all together. So what is doubling time? Let's just say what doubling time is in general right now. It is the time it takes for a population to double. And you can get this information from a graph or from an equation. And here we're going to be getting it from an equation. So we're still going to just be working with y is equal to a times b to the power of x. And let's take a look at what we're given. So we're given A is 50. We started with 50 ants. And we're told that it grows. So this means that b is 1 plus r. And our growth rate is 3.7%. So b is going to be 1 plus 0.037. That's 3.7% divided by 100. And b is equal to 1.037. Now, we haven't been given x because that's what we're looking for. Like, what is x? We need to figure out x. We need to figure out our time. Now, we're being told that the population is doubling. So that means we need to find y. So y is just going to be double our initial population. So it's going to be 50 times 2. So y is equal to 100. And this is, I'm going to just write what I said, double the initial population. Now, let's put what we know into our equation. So y is 100, a is 50, and b is 1.037, and then we have x. Now, what we want to do is we want to simplify it a bit. And we're going to do that by dividing both sides by 50. Okay, so what you do to one side, you must do to the other. So 100 divided by 50 gives us 2. And we have 2 is equal to 1.037 to the power of x. So now what we're going to do is we need to figure out what x is, because that's going to be the time it takes for our population to double. And we're going to do this by just doing guess and check. So guess and check. What this means is you're going to be putting some numbers into your calculator for x and seeing what it gives you. And you want to see how close you can get to 2. So we want to look at when x is equal to 5. And truthfully, I just picked a number out when I was making this up. And I said, okay, let's see what happens when we have 5. So when x is equal to 5, This means you have 1.037 to the power of 5. Plug that into my calculator. That gives me about 1.199 and so on. So that's not 2. It's not very close to 2. I'm going to go higher to get my number higher. So now I'm going to try when x is equal to 10. Okay, so that means 1.037 to the power of 10. And that gives me approximately 1.438 and so on. Okay, so I increased my x value by 5, and I still didn't really go up that much. I needed to be closer to 2. So I'm going to jump by 10. So let's try when x is equal to 20. So 1.037 to the power of 20. That is equal to approximately 2.068 and so on. So many more decimal places later. Well, look, we have 2.0. This is darn close. So we are going to recognize this and say, look, yes, it's not exactly 2 on the dot, but it's very close. So x being equal to 20, that's going to be our answer. Now, in this question, I didn't say that we needed to round to 1 decimal place or a whole number, so do pay attention on the instructions in the question. But here we got really close. So we need to write a summary statement. Therefore, the doubling time is 20 weeks. Okay, and notice how I showed my work at Guess and Check. You need to do that, right? You need to show your work, especially with word problems. If a question's worth more than 1 mark, you need to show me some work. Lastly, we have a question on half-life. And again, for more information on half-life, go back to the notes. So the half-life of iodine is 8 days. If we start with a 500 gram sample, how much is left after 40 days? So let's just really quickly define half-life. So half-life, excuse me, is the time it takes for half the initial amount of something to decay. So these are decay or decreasing questions. We are still going to be working with or thinking about at least y is equal to a times b to the power of x. But in this case, we're actually going to use a chart to help us figure out how much is left after 40 days. So there's different ways to do it, but this is the way that we learned it initially in class, so we're going to stick with it. So let's still underline the important information we're given in the question. We start with 500 grams. The half-life is 80 days, and we want to know how much is left after 40 days. So we are going to create a chart where we have time in days on one side, and then on the other side we have our amount, and our amount's in grams. So we start out, so at day 0, we have 500 grams. Now, after 8 days, we know that we have half that amount left. We don't know really what happens. We could figure it out, but we don't really know what happens on day 2, 3, 4, 5, 6, 7. But after 8 days, we have half the amount. So we're going to be dividing 500 by 2, and we get 250. We're going to continue doing this. So after another 8 days, we're up to 16 days. And after another 8 days, we are going to divide by 2 again. So we get 125. After another 8 days, now we're up to 24 days. We're going to divide by 2 again. We get 62.5. Okay, don't round any numbers yet. After another 8 days, now we're up to 32 days. And I'm going to actually just put a little arrow here that we're adding 8 days each time. So after 32 days, we're going to divide by 2 again, and we're at 31.25 grams. And then after another 8 days, okay, look, we are at 40 days, and we have 15.625 grams. So, here we are. Okay, so after 40 days, we have 15.625 grams left, and it didn't tell us to round, but we're going to default to rounding to 1 decimal place. So therefore, after 40 days, there is approximately 15 points, oops, that 5 is a little wonky, 15.6 grams left.